Hey folks, this is Philip. I'm glad to be your host today. I'm trying to walk you through the process of running your own server and getting your own skeleton data live fed into touchdesigner without any kinect, which might be interesting for those people who are actually running a more elaborate zoomed in or far away camera system or just want to gather data from, well, different imagery. So this is Linux Mint. We are running Linux Mint because this is one of the easiest installs. I have Docker and Docker Compose installed, and I also installed the interfaces server that you can download from the GitHub link in the description. It's very easy to install it. Then we have a cable connection to the network that I'm using here. The IP will be coming in handy very soon. And I'm running OBS in the background to have an image. This is why this is recorded with a camera. I'm not a dancer, so my webcam wouldn't record anything that you want to see. But here we have Ludovico Pace, the ballet master of the ballet in Hanover, and we are trying to use this as an input, and we're pretending to have a camera connected to the system that goes into the webcam connector of your server. In this case, it's a loop running on OBS, okay, but you can actually just connect anything that, well, feeds into what we'll be using as our server. I'm opening Chrome and I'm just accessing my local host, which will bring me to this site. And the most interesting part of it is the MediaPipe live scan, which I'm going to introduce you to. It's this site where you have to change the IP of your Websocket connection to the IP that we're actually running. So I'm going to do this. Also enter the port, which is 4242. If you know, you know. And now we can connect the WebSocket, and now we start the webcam. The webcam, as I told you, is the OBS stream, the virtual camera of OBS, and you already see the overlay over Ludo. And if I now start broadcast, we're broadcasting the movement data, well, all the limbs, all the joints of the skeleton as WebSocket to our connected machines. In this case, I'm running touchdesigner on a MacBook Pro. Let's start with a WebSocket dot. In this WebSocket dot, we will address our IP as we stated it on the server, and let's go for the port. Inside joke, you might find out. Now we are catching 10 lines. We don't need 10 lines, just let's go back to one line. And with that being said, let's go into a select to reduce this to just one, because I'm a lazy person and I don't know how to code. So from here, I kind of lose it because I don't know how to deal with JSON files. So if you have anything more elegant, just let me know in the comments. Well, we go into a JSON. This is our JSON file. We try to separate our payload. Let's go with brackets and a wildcard in there. And let's go into a table. And now we end up with a table where in every column there is this kind of array that represents the points of that joint. So from this one, we run into a convert to bring it into a proper table format, and we separate the cells by comma. So this makes this being a table with a column for every value. Now here's the hack. I don't know how to solve this problem with JSON filtering, so maybe you know how to do it. I was kind of ripping my head off. It didn't work. I'm going with a substitute. I'm going to substitute certain elements of my string with, well, with empty space. It's not the most elegant solution, but it's definitely working. So we also delete the parts where we here we go. The epsilon and the Z. This way we end up with a kind of clean table that just has numbers in it. And from here, because we're nice people, we go into a null. And then go back into the job world, because this is where things are a little more easy. So here we are, with everything collected in one big channel. So this is not what we want. So we want channel per column, like this. And we want to start with the values also in every line. So now we have obviously values that are identifying themselves, because the Z value is negative. That's something that happens with this algorithm we use. So obviously things are sorted out nicely. From here on, I send it into a shuffle. Oops. To then sequence all samples every third channel. And from here, we go into a select to sort things a little. Here we choose channel 1. So this is channel 1. We go into another shuffle. And we swap channels and samples. So now we have all the X channels here sorted out like this. From here, just because sometimes we might need it, we go into a filter, but we disable the filter right now. And also we go into a math, because sometimes we have to kind of adjust those values. And from that math, we could actually be nice and go into another null. So we are. Let's insert a rename in between this and the null. And let's use the file that I will link below so you can download it. It's the file of all the joint names by MediaPipe. So it's a lot easier to do that. I'm going to insert it. So we're going to insert the file here. Let's put a null here if we have to change something. We never know. And for the rename, we are referencing our null. So it's operator null3 dot text. So that's obviously an expression. And now we end up with the names of it to make this a little more kind of reasonable and make it more explanatory. We add in another rename. And we rename everything to whatever it was plus tx. So we are. Now we end up with a bunch of channels that are called the proper names. And before we go on, we could just copy this and put it in here 3 times. This is channel 2. And this one is channel 3. And back here we call it tx, ty, tz. Let's put in a merge, connect those, and here we are. Everything disordered. Let's go into a reorder. And from this reorder, we choose base name sort, which brings us back to the situation that we were at. So this is tx, ty, tz of the, and now we are following the alphabetical order of the things that are defined as our channels. From here, we go back to a shuffle because we want things to be in one thing. Wait a second. Shuffle. Here we are. I'm German, so I made those mistakes. And here we go, like sequence all samples every third channel. So now we end up with sorted channels. Let's go into a null. And let's see what happens if we're using this. Put in a box. That box goes into a transform. The transform goes into a null. The usual sequence that we put here. Transform, we just already scale the whole thing to 0.01 because that makes kind of sense. Maybe. Correct me if I'm wrong. And from there we go into a geometry. Choose the instancing and pull this in here and go X, Y, Z. And you can already see something happening here. There's something moving. It's upside down. This might be because the Z values are in the wrong direction. Instead of changing the Z value direction, I will just rotate the whole thing 180 degrees. It kind of made sense for me to do this. And to see why this is actually, he looks a bit skinny right now. So I don't want him to be skinny that way. And also the Z channel is a little joppy. So we go back to where we had our math and our filters. And I turn on the filters on the Z axis and well, just use a small filtering here. And on the math, I multiply this something by 2.3, I think is the thing. So because MediaPipe relates every point's position to the width of the image, it will, like usually it will spread the -1 to +1 of the values in between, well, a 16:9 image. So that's why he looked a little skinny and compressed. So let's add in a camera. And as usual, I like to have a kind of base to my camera. So I love to put in a null and just constrain the camera to the null. Let's put in a material. In this case, the constant material would work fine. So we put in this material, go for a render top. Here we are. And then we do the usual, we put in a composite on over and do something nice, perhaps a ramp. And we have a circular ramp that holds somewhere. And I like it the other way around. Let's put this on HD. I know this is not the right way, but it's faster that way. So we're actually now turning this around. Boop. Something like here, and then to this. Okay, put the over on it. And then we output this and display it. So now it's a little shifted. That has to do with the values that we are receiving. So change the math if you want to. In this case, I'm lazy and I'll just adjust the position of my null and shift my mannequin in the middle. Just take the camera and move it a little closer. Here we are. And now with the null, I can, if I wanted to, just rotate around a 3D mapped, well, square, whatever, block situation, and it follows the choreography. So that's what I wanted to show you. It's an evil hack right here. So if somebody can tell me how to solve this a little more elegantly, the Json filter should be put differently. I have no idea how to deal with what I'm having here as the JSON file that's being handed over here. So help me if you can. If not, just use it like this. From here you can go different ways. So here we are, a well, pretty precise representation of the dancer with only the joint positions in space without a kinect. Here you go. I hope that was useful for you. Subscribe to the channel if so, and I'll be seeing you next time.